All right, welcome back. So first thing I'm going to do is I'm actually going to comment out this line of code here because I don't want my serial monitor to be cluttered with a bunch of nonsense. I know that one's working, so I'm good. Okay, let's go back to our flow chart, and we've just done these two. So we added them to make the left thruster speed, and we subtracted to make the right thruster speed. Now we need to ask if either one is greater than 100 and if it's less than 100. Okay. So to do that, we're going to say if, and we're going to start with our left thruster, Control C, Control V, is greater than 100. And normally I'd put a semicolon here to end the line, but this is an if statement. I want to open the if statement. So I'm going to do a curly brace here, enter. Notice Arduino added the closing curly brace for me. Anything I put inside here will run if this is true. So if that is true, we want to go F thruster speed equal to 100. We set it back to 100. Now the next thing we want to do is do another thing. So this is, well, we'll do it later. We want to do another one of these. And we're going to say if the thruster speed now is less than negative 100, we want to set the thruster speed back to negative 100. So if it's like negative 150, it should just be negative 100, meaning full speed backwards. Now, so the question here is, should we have two different ifs or should we combine them with an if, else if statement? In this case, if this is true here, we know for sure this isn't true. If it's greater than 100, it's definitely not less than 100. So this is how we decide whether we want to do an if, else if. So if this one is true and this one would never be true afterwards, we can do an if, else if. The value of doing an if, else if statement is that if this is true, we don't even bother the Arduino with the energy and time and resources of even asking this question. It knows to just skip it because it's an else if statement. All right, awesome. So let's put a comment in here. So we can say here, this keeps the speed to speed less than I don't know, 100. I don't like that. Let's do, I'm going to do corrects the speed if it is more than 100 or less than negative 100. I'll put percents in, and later on I'll remember, oh, that's why I did that. Okay, that's great. And now I'll do the same thing, but for the right thruster motor. Line the if up properly, and then if the, I'm going to do R's on all of these, and I'm all done with that part. Now the question is, should we add these two to the bottom of this one in an if, else, else if, else if, else if statement, so that if one of them runs, it skips the rest. In this case, we don't want to do that because if the left motor is greater than 100, it might still be possible that the right motor is also greater than 100. So we'll evaluate them separately. Although, is that true? That may not be true, but I'm not going to think about enough to move on to do anything about it. If you think about that and you find that these could never happen if one of these happens, then you can combine it to an else if up here, and you'll have slicker code that runs faster and cleaner because it's not doing extra steps. All right. So we need to test this. So we're going to take this LR serial print from up here because it's the same left thruster and right thruster here. And we're going to put it down below here. And we're going to click on the line and uncomment it. And we're going to run this. Now what should happen is when we're rolling that joystick around, we should never get values that are greater than 100 or less than negative 100. So we need to check all the way around and make sure that we're maxing out at 100 and negative 100. Or minimizing out at negative 100. How do you say that? I don't know. All right, so I'm 100, 100. That's no big deal. Yep, so as I rotate around, you can see I don't ever get anything less than negative 100 or greater than 100. Perfect, code's working great. Love it when it works. Oh, yay. For some reason, my Arduinos like to disconnect right now. I'm going to go ahead and comment this line out. And then let's go back and see what we're doing next. So we've done these two if statements. We've done this and this. We need to now map them from negative 100, 100 to 1100, 1900. So we need to do that mapping now. So here I'm going to tab over and I'm going to say map. And what I'm going to map, well, I'm going to start with the left thruster speed. Always keep them in the same order. Map L thruster speed from the current range is negative 100, 100. And I want to map that up to 1100, 1900, which is what the motor actually needs. Let's go find a map. Here we go. Control C, Control V. So this is converting the percents into motor speed values. Get rid of that last part. And now, again, Arduino would do this happily and then forget it. We got to tell it where to put it. And the interesting thing in computer programming is that you can put it right back into the thing you already used. Because remember, this is a before and after. So this is the thruster speed number that it was before. It'll map it to a new number and then erase the number it just used and put it in the new number in that space where the old number used to be. Boy, did I say that confusingly enough there? I'm now going to copy and I'm going to paste that. So Control C, Control V, V, and then R and R for the right thruster speed. Awesome. And now we need to see if this is working. No. Yes, we need to see if it's working. So I'm going to do the same serial print down here. I'm going to uncomment this one. And I need to relaunch my Arduino Create agent so my board can reconnect again. And I'm uploading. Now we're looking for is that when we roll up, they should both be 1900, and then we go to the right, one should be 1100 or 1900, and should change with these motor speed values instead. We won't try and keep track of, as long as they're in that range of 1100 and 1900, and they look like they're changing, we're going to assume that they're all working right. Yeah, look how nice that looks. Awesome. Okay. So click off of that. I'm going to comment that out. And now go back, see what we got. Okay, so this is where we're going to be testing whether or not we're close to 1500 or not. So I'm actually going to bring the monitor back up. Yeah, so my values, I'm going to turn the auto scroll off, are going from 1484 and the right is 1508. So I think I'm just going to control them around 75 and 25 like I did before. And that way I'm going to come up here and steal that code from up here. So here's that code right here. Oh, we didn't leave a comment before. Let's leave a comment. So this sets any values close to off, which is 1500, to 1500. So it makes them off. If they're close to off, it makes it off. And I'm going to just copy that, come down here and paste it. And this was great for the front thruster, but we want this for the left. So I'm going to change all these F's to L and then do it again for R. And here I definitely don't want the else if in there because the left and right could both be, they're both just separate. So we want to keep those ifs separate. So we're doing both every single time and not one or the other. And then here, yeah, L and R we need again. So let's test this out. At this point, we should have fixed this starting thing. They should start at 1500 guaranteed now. I'm going to uncomment this for a second, upload this to our thing. So again, when we start out, instead of being 1484 and 1508, they should be sitting at 1500, both of them. Oh no, I didn't change the ranges. So notice one of mine is at 1484 because I have mine at 1490 from above. So that's the problem of having it too close to the center. So I'll fix that real quick and then we'll move on. Let's see. Whoops. It does not like when I do that. All right, so we'll do this one at 75. 75, and this one I'm going to do at 25 and 25. All right, so I think that is all good. I'm going to comment out this serial print down here and then open up a few more lines of code. And that takes care of this part. So we set it back to 1500. Now we just need to do the right microseconds. We'll do that in the next video.